I want to do a part of Project 6, first part, and what you have is here a table, and it's a frequency table. This is not a contingency table. It has 5 different bags all listed here, and we need to look at those separately. So for bag 1, we're just looking at this right here, where we have 7 green, 20 orange, 10 red, 7 purple. So Skittles in this bag. So the first thing you need to do is count up how many are in the bag. So we got 7 plus 20 plus 10 plus 7 plus 14, and that gives us 58. Now, if we want to find out the expected value, there's supposed to be 20% of each flavor. So we would expect the exact same number of each color in that bag. So we take 20% of 58, and let's just move this up here. So 20% of 58, or 0.2 times 58 is 11.6. So I'm going to compute the chi-square test statistic for goodness of fit test by using the calculator here. If you don't have the GOF test or the goodness of fit test on your particular calculator, you can just do this computation out. And what it basically is we are looking at each color and how different it is from 11.6. We're adding up those differences and then coming up with a test statistic. So you'll see the first one was green, so we take 7 minus 11.6 squared divided by 11.6. So this first part right here is for green. Plus, and now orange, 20, so 20 minus 11.6, so we get the deviation, square it, divided by 11.6. So this is really just like the variance formula. Red's 10, here's 10 minus 11.6 squared, plus, or divided by 11.6, and then plus, so we sum up all of these differences, or these squared deviations, 7 minus 11.6 squared, and then the last one, yellow, 14 minus 11.6 squared. So we add it all up, we get 10.448. That's our test statistic. And to get the p-value, we can just go in our calculator here, and the chi-square test is going to be a right tail test. And so we just need the area to the right of this test statistic. We're going to go second function, distribution, go down, chi-square CDF, cumulative density function. This will enter. So we're going to put in our test statistic, and I need to move this up a little bit. 10.448, comma, and then E99, because it's going from this point off to infinity to the right under the chi-square curve or distribution, and then comma the degrees of freedom, which is 4. We hit enter. Our p-value is 0.0335. So this is, if we use a significance level of 5%, 0.05, our p-value is less than 0.05. So we would reject the null hypothesis that there is no difference between the observed and expected values. So what we're saying is that yes, we would reject that this bag has an equal number of flavors in it, or all the flavors are equally contributing to that bag. So again, we're going to reject that hypothesis and say that there's a significant difference from what's supposed to be in that bag. And so you kind of do that the same for all those bags, and you find out basically that you're going to reject these first 4 and accept the last one. And find out here that, you know, these samples are very small, and with chi-square it does affect, even though we don't use degrees of freedom, but we would really should look at sample size. Now, degrees of freedom, this is our table would be a 2 by 5.